Okay, I have another example to show you of the if statement, and it has to do with wind chills. And what I'm showing you here is an actual equation used by the Weather Service to determine the wind chill in the wintertime. You know, when the temperature is cold and there's a strong wind outside, the temperature feels a lot colder than the actual temperature, and this is the calculation for the wind chill. So first off, I took this program out of the textbook, and so I took a little screenshot of the problem here, and let's see if I can make this bigger. Right there and right there. And this is the formula, and who knows who came up with this formula, but it's a complicated formula. And we have powers here. We have V raised to the 0.16 power. Who knows? Okay, it does not ask that question. And then, so in order to use this formula, we have to have the actual temperature and the actual velocity of the wind. And then you stick those numbers into this equation, and out comes the wind chill outside. But this equation is only valid if it cannot be used for wind speeds lower than 2 miles an hour, or temperatures below this -58 or above 41. Otherwise, the number that you get out of this is meaningless. Okay, so just accept it. This is what we're going to do. We're going to assume that this is true, and I think it is true. We're going to come over here, and I'm going to literally do what the problem says, is I check for the range of the temperatures in Fahrenheit. Okay, and you notice I got a little error here. See, and I hover over that error, it says input's never closed. Well, let's close it. Okay, after we hit enter the temperature, well, here's the deal. I'm going to put that over here. Input dot close. Okay, and I think that error went away. It did, because if I go through my indentations here, yep, that's where it is. Input, scanner. Okay, good. Very, very good. Now, here's the way I wrote the program. I could have written the program asking for the Fahrenheit temperature and at the same time the wind speed, and then closed my input. But the problem is, if the guy enters a bogus number like this, don't waste the guy's time entering the wind speed if the temperature is bad right off the bat. So that's the approach I take. Okay, this guy here checks to see if Fahrenheit's within the proper range. If it's outside that range, then you can do this. Okay, this is a degree symbol over here, I believe, if I run this. That's the degree symbol. Let's see, we'll say 0 degrees Fahrenheit within the value, let's say 30 miles an hour. Okay, then I don't know what this is. This is some kind of bogus thing here. Oh, let's do it again. Oh, it's got to be bad. Bad. Negative. That's a very cold temperature. I don't know what that schmaltz is, so let's go ahead and get rid of this and get rid of this. Okay. All right, so that should look better. I'm not sure how that happened, but you know, with computers, there's stuff always bizarre happens, and we just have to accept it, part of our life. That's why they're going to be paying you the big bucks to overcome these issues. So, okay, if it's a bad temperature, we output this message. Now, a lot of people don't like this or. Either the temperature is super cold or the temperature is too hot, then we don't bother with this formula down here. I could have written it like this. I could have written it like this, like so. Okay. I could have written it like this. If the temperature is too cold, let me save this. Let me save this over here. I don't want to wait. I don't want to do too much typing. I think I just erased it. Edit, undo. Okay, let me copy this. Copy, and let's paste this right in here. All right. And then salvaging that if statement there. If it's too cold, I'll put the error message. Else, if it's too hot. See, remember, this might look like programming to you, but this programming has to mean something. I highlight that. You say Fahrenheit's bigger than 41, but I interpret that as being too hot. That's what you should start thinking when you do your programming. This would work as well. If execution comes here, then what happens is you're not in the proper range. All right? Now, can you see the problem with this technique? Okay? First off, you don't need these braces. You don't really need these braces here or here because you only got one statement. But that's not the issue. The issue is I'm doing the same thing twice. Okay, and when you program, you try to avoid doing that. Don't type the statement twice if you unless you really have to, or more than once. So let's go back to what we want, and that way there. I think I can do a Control Z to undo. Yeah, but do a bunch of Control Zs. There it is. I'm back to where I was before, and I only have this statement done once. I'll leave the braces there. It doesn't hurt anything. If execution comes here, you're within the proper range of the Fahrenheit. Now we can safely say, hey, let's find out the wind speed. Now you might say, well, why didn't I put the input.close there? Okay. The problem with closing here is that the only time the system will close is if the guy enters the Fahrenheit temperature properly. Okay, and if he doesn't enter it properly, then this input.close, okay, this is but basically what people would tell me. Why don't I just do it there? Source, okay, and I don't get any compiler errors. But the problem is, do you see the problem? I see the problem. If it's bad temperature, you execute, you bypass all this else stuff, and you never close the file. Okay, you want to close the file regardless of where you are in the program. So you have to follow along. See, this unconditionally gets when you get to line 32. Who knows how you get to line 33? I could have got there whether I had bad Fahrenheit or not bad Fahrenheit. I closed at the very end. So do it that way. Now I check to see if the speed is less than 2. If the speed is less than 2, then got to output an error message. Can't use the formula. Otherwise, execution. I got the proper speed, I got the proper Fahrenheit, and so I go through and I code that formula. You're just going to have to take on faith that that formula is coded correctly. Let's come down here, and let's put the plus sign over here, and move this plus sign. Come on, right there. Get rid of that. That should match whatever is in this picture over here. All right. And so display the result. We're good to go. Let's see if this works. And I think it does. I would say 0 degrees. That's well within the range of Fahrenheit. And if I show at normal temperature, 10 degrees, 10 miles per hour, it feels like negative 15, negative 16. Okay, that problem is done. Let's bang out another one. A common problem is to sort things. And so let me come back to the sorter. Let's get rid of all this stuff here. Okay. The common problem is sorting things. So here we have sort 3 numbers. Okay. Same issue here with the sort 3 numbers. Make it bigger. Okay. I'm going to put the input.close here because I'm not going to do any more input and I don't have any other path here. So I could enter these numbers in different orders. Okay. Say 15, 22, and we want to out them sorted in ascending order. Okay, let's take a look at this. This is basically how you do a problem like this. We check number 1 is greater than number 2. If that's the case, number 1 is certainly not the first. Shouldn't be considered number 1. You need to swap those 2 values around. This is code that swaps. Understand that code. Swap values in variables. You need a temporary value to store number 1, move number 2 into number 1, and take that temporary value and store it into number 2. Okay? Understand that. That's very important in programming, swapping things. If execution goes to line 19, it's guaranteed that number 1 is less than number 2. It's guaranteed. All right? Either it was already smaller than number 2, or you did the swap to make it less than. Number 1 is less than number 2. Now I'm going to take that, what we consider to be the smallest one, and see if it's bigger than number 3, the third value. If it's bigger than number 3, then you swap them. Okay? Now what you got in this case is a guarantee that number 1 is less than it's actually less than both other values. Both other values. It's guaranteed that number 1 is where it should be. But that's not to say that we have to do a one further test. Okay, we have number 1 where we found number 1 to be the smallest, but with all these swaps, you don't know which one's the next smallest. So what we need to do is another one of these comparisons. If number 1 is bigger than number 3, then number 2 is bigger than number 3, then number 2 is in the wrong spot. Swap those things around. I do the swapping of those variables, and now when you get to line 34, it's guaranteed that we're going to output those numbers in nice sorted order. I showed a printf statement here, and this printf statement, I may as well talk about it quickly. I want to output these 1, 2, 3 values. The first value in the printf is what's called a descriptor. It's got to be a string. Notice that it's in quotes. And what happens is you can put inside the descriptor anything you want, like sorted numbers, space. Now, when you see a percent sign, that percent sign indicates that I would like to match the first value in the remaining list, the first value, the first parameter in the remaining list. And when since this is an integer, you need to put a D there for decimal. I don't know why they can say %I, but it's %D for integers. Put a space after that. After you output that number, put a space. Then we have another percent that matches the second value. So we output that number, put a space. Okay, number 3 is the third percent, and we've output our numbers, nice and sorted. And it doesn't matter how you do it. Let's make the 55, 34, 12, and they come back in sorted order. Okay. So we'll stop the video here, and we'll see you in the next video. Take care. Bye.